Hi everyone, Notes 1.7 are on exponent laws, and this note starts on page 10, but we would have done all of this stuff together on page 10 in class. So we're going to actually take a look at page 11 in this video. So just a reminder that the product rule says that if we have two monomials being multiplied together with the same base. So for example, if we have a to the power of m times a to the power of n, we have to add our exponents. So what this means is it would be a to the power of m plus n. So my base stays the same, and then we just add this m and this n together. So for example, if we had 5 to the power of 7 times 5 to the power of 8, that would become 5 to the power of 15. Again, because we are multiplying 7 fives, and here we are multiplying 8 fives, so altogether we have 15 fives. So now for the quotient rule, this one says that if we have a to the power of m divided by a to the power of n, we keep the base the same, but this time we subtract our exponents. So for example, if we have 5 to the power of 10 divided by 5 to the power of 8, that would become 5 to the power of 2, because here we've got 10 fives being multiplied together. Here we have 8 fives being multiplied together. 8 of those fives cancel out. We have 2 fives left over. And then lastly, if we have a power to a power, this means that if I have like a to the power of m raised to the power of n, we have to multiply our exponents. But our base is still going to be the same. So for example, if I have 5 to the power of 10 raised to the power of 8, that means it's going to be 5 to the power of 80, because this is saying we've got 5 being multiplied by itself 10 times, and then we've got 8 sets of those 10 fives, so altogether we have 80 fives. So let's go ahead and apply these rules. So in our first example, we've got question number 17. All of this stuff right here, this is a little bit this can be kind of scary, kind of confusing. So if you notice here, it's like we've got some invisible brackets here, and according to order of operations, we always do our brackets before we do anything else. So let's go ahead and do our brackets here. Now, since this is all multiplication here, when we multiply, we add our exponents, right? Because here we've got 2 fours, 7 fours, and another 1 4. So here I would add my exponents 2 plus 7 plus this invisible 1. 2 plus 7 is 9 plus 1 is 10. So I've got 4 to the power of 10. Notice the base stays the same. Why is that? Because this is saying 4 times 4. This is saying 4 times itself 7 times. And then this right here is saying another 4 right here. So altogether we have 10 fours being multiplied together, not anything other than 4. Same thing in the denominator here. I have 3 fours, 1 4, and 4 fours all being multiplied together. So we can just add our exponents. 3 plus 1 is 4, plus 4 is 8. So this is 4 to the power of 8. Lastly, now that I've figured out, I've simplified my numerator, I've simplified my denominator, I can go ahead and do my division. So when I divide, I have to subtract my exponents. So 10 minus 8 is 2. My base stays the same. So my answer here is 4 to the power of 2. In our next example here, we've got an entire numerator and an entire denominator that both need to be simplified. But I have coefficients. So I have to make sure to multiply coefficients. How do I know that I have to multiply those coefficients? Because of these multiplication signs right here. Let's go ahead and think, what are my coefficients that I have here? Well, I've got a coefficient of 3. Remember, your coefficient is the number in front of the variable, a coefficient of 5, and a coefficient of 6. So here, when I multiply 3 times 5 times 6, it's 15 times 6, which is 90. Or I could do, by the way, I got 15 by doing 3 times 5. 3 times 5 is 15, times 6 is 90. Or I could do 5 times 6 is 30, times 3 is another 90. I don't mind if you use your calculators for this. And then I want to see what can I what bases do I have here? So I've got x to the power of 4, and I'm going to look in the numerator and see, do I have any other x's? I sure do right here. It's x to the power of 6. And when we multiply, we add our exponents. So 4 plus 6 is 10. So this is x to the power of 10. And then we also have this y, and this is y to the power of 3. Now there's no other y, so I would just write that down. Now I want to do the same thing in my denominator, okay? So I want to multiply 2 by 3, which is 6, and then multiply that 6 by 5, and I would get 30. So here, this would become 30. Now let's go ahead and look at our x's. And all I have here is x to the power of 2. So here I can just write x squared, or x to the power of 2. And then I also have y's. And here I've got y and y to the power of 3. And just a reminder, if I have y, this means y to the power of 1. So right here, if I've got y to the power of 1 and y to the power of 3, 1 plus 3 is 4, so I get y to the power of 4. So now let's go ahead and divide. So 90 divided by 30 is 3. Same thing, make sure to divide your coefficients when it's time to do division. Pretty much what I'm trying to say here is that these exponent rules only apply to the exponents. The coefficients are just like regular numbers, so we do whatever operation it says. And so here, since this says divided by, we divide the 90 by that 30. Okay, and now we'll use the exponent rule. So x to the power of 10, x to the power of 2, same base. When we do division, we always subtract. So this right here ends up becoming x to the power of, 10 minus 2 should be 8. And then here, same thing, y to the power of 3, y to the power of 4. So we get y to the power of negative 1. The negative does matter. Now, the negative exponent we're not too concerned about for right now. We'll talk about it a little bit more in detail, but that's going to be something you're going to be learning about in higher level math. All right, same idea with this question right here. So this b that we see right here, this b to the power of 5, it has an invisible coefficient of 1. So if there's no number in front of it, it means that the coefficient there is 1. So same thing, we still want to multiply our coefficients. We've got 1b to the power of 5, 4a to the power of 4, 9a to the power of 3. So when I multiply my coefficients, 1 times 4 is 4, 4 times 9 is 36. Now I'm going to go ahead and multiply my bases right here. So a to the power of 4 times a to the power of 3. Because they have the same base, I can add the exponent. So I get a to the power of 7 because 4 plus 3 is 7. And then here I end up getting b to the power of 5. There's nothing else like it to multiply with it. So I'm just going to write down b to the power of 5. Now, in my denominator, I have this b squared right here has an invisible coefficient of 1. So here I'm going to multiply the 2, coefficient of 2 that I see here. Sorry, I didn't mean to highlight that a, times this 1 multiplied by the 6. So 2 times 1 is 2, times 6 is 12. So up here, I'm just going to write that this is 36. So here I get 12, and then I'm going to multiply a to the power of 2 by a to the power of 2. When you multiply, you add your exponent. So this is a to the power of 4. And then here I'm going to multiply this b to the power of 2. I'm just going to add that on because there's nothing else that b to the power of 2 can be multiplied by in the denominator. Now, all I have to do is just divide that 36 by 12. I end up getting 3. A to the power of 7 divided by a to the power of 4. You subtract those exponents, so you get a to the power of 3, or a cubed. Same thing with the b's. Subtract those exponents. 5 minus 2 is 3. And this right here is my final answer. All right, this one's a little trickier because we have a power to a power. So, but if you look inside of these brackets here, that a to the power of 4 times a to the power of 2 can get simplified a bit more. So here I get a to the power of 6 because when we multiply, we add our exponents. So right here, I've got a to the power of 6 raised to the power of 4 all over a to the power of 8. Notice how every time I do a step, I copy everything else down so I don't get confused by what's going on here, okay? So now I have a power raised to a power, and when I have a power raised to a power, I have to multiply those exponents. So right here, this turns into a to the power of 24 all over a to the power of 8. Notice how I haven't touched that denominator yet, or I haven't done any division yet. And the reason why is because I want to simplify the numerator and the denominator as much as possible first before I do any division. So if you look right here, in this numerator right here, I simplified this right here. I could not take this any further. That's as simple as it could get. And same thing with this one right here. This is as simple as it could get. So over here, now I've gotten to a point where my numerator and denominator are as simple as they can get, and they have the same basis. So a to the power of 24 divided by a to the power of 8. When I divide, I subtract my exponents, so I get a to the power of 16, and I am all set for this question here. Okay, in this next one right here, we want to simplify that numerator and simplify that denominator. So I'm going to do it all together in the same line. So if you look right here, I want to multiply my coefficients up here. So 3 times 8, that will give me 24. So I know here this will give me 24. Now let's look at our f. So here we've got f to the power of 4, and this right here is f to the power of an invisible 1 for my exponent here. So this becomes f to the power of 5. And then lastly, in the numerator here, I've got this g to the power of 3, g to the power of 4. When I multiply, remember we add our exponents, so this is g to the power of 7. Now, in the denominator, pay really, really close attention to what's going on here. So we have something to the power of 2. So that means that everything inside my brackets is going to get squared, including that coefficient. So this 6 has to get squared. So 6 squared is equal to 36. So this would have to be 36 right here. And then remember, when you have a power to a power, you multiply your exponents. So here we've got f to the power of 2, but that's being raised again to the power of 2. So 2 times 2 is 4, so I get 4f to the power of 4. And same thing with this g right here. This is g to the power of 3 being raised to the power of 2. When you multiply your exponents, you get g to the power of 6. 3 times 2 is 6. But let me explain to you, let me show you why this really works. So 6f squared g to the power of 3 times 6f squared g to the power of 3. If you think about it, it makes sense, right? Because 6, first of all, why did I write this out twice? Because this squared right here is telling me that I have to multiply it by itself, right? So I'm just showing you another way as to why this works. So now here, 6 times 6 gives me this 36 that I get here. F squared times f squared, 2 plus 2 is 4. That's how we get this f to the power of 4 right here. And then g cubed times g cubed. You add your exponents, 3 plus 3 is 6. That's how we get g to the power of 6 right here. Okay, fantastic. So now that I've done that, I can go ahead and get my final answer. Now, when I divide this 24 by 36, I get a decimal. It doesn't divide out evenly. However, 24 and 36 are both divisible by 12. I can reduce it. So when I divide 24 by 12, I get 2. When I divide 36 by 12, I get 3. So my answer here is 2/3. And now I can just subtract my exponents. So f to the power of 5 times divided by f to the power of 4 is f to the power of 1. I don't need that 1 there, so I could just say f. And then same thing with the g's. G to the power of 7 divided by g to the power of 6 gives me g to the power of 1, or just g, and that's my final answer. So we'll save question number 22 for class, but I strongly suggest that you give it a shot because the best way to learn how to do something is by trying it out and making mistakes and getting those mistakes out of your system. So yeah, I'll see you in class. That's it for this video, and I hope you have a great day. Bye.